Hi, my name is Jack. My Chinese name is Liu Shurui. And today I'll share some experience in the past 2 years using Kubernetes in my product environment. Actually, introduction. Here is the agenda. First, introduction, self-introduction, and later I explain my environments, my Kubernetes environment, and some lessons I learned in the past 2 years, 2+ years. Okay, self-introduction. Okay, I work in the ByteDot, a small company, solution architect. My experience as a solution architect is about 10 years, 10+ years. I'm very interested in the cloud, Kubernetes, and DevOps, SIE, and this kind of thing. And my social income. Yeah, GitHub is here. Thing about me. Okay, so here is my environment. Basically, remind you, our system is running on Kubernetes. The cluster, I prefer to externalize our status in using managed services like S3, RDS, Redis, like that. We also consider using the EFS and in our environment, try to adopt a lot of new things into my environment. And the DevOps principles, the 12 factors, and beyond. Here are some key things I use in my environment. I also I'm still learning and try to use this kind of thing. I mean, SIE principles and platform engineering. There are a lot of new things. Maybe you encountered it before. However, this case is I cannot find the solution in the link. Maybe I'll give you the link. You can. Okay, you cannot see that. Okay. Okay. Zero. It's a better. Yeah, makes sense. Sorry. Yeah, here I have several common reasons. My case is I cannot find the solution from here. You mean I mean that I cannot use the kube control get events and kube control get logs from the course. So here is my reason. Here the actual reason.
Presentation.
Yeah. Okay. After try all this all the measures in the link, so I cannot find a solution. So I look through the status of the pod status. So I find the error code, and And finally, I figured out the reason for the system, which is the code, the bug in our code. So make some change in the, I mean, the whole point here is that sometimes you need to check the last state, the error code. Yeah, I think, yeah. I mean, the second lesson I learned, yeah. So let's do the observability stacks. Usually I prefer using the in cluster way. I mean, I run the hierarchy stacks in the cluster. So what's the catch? Definitely, there's always a trade-off. Yeah. Here write down compared to two-way. Yeah, you can see earlier. I attended several interviews, being asked a lot of Chinese things, and finally I figured out that I should prefer using this way, the out class way. If there's something wrong, you still can check the log. You can get the metrics. If your class the observability stack in the cluster, if there's something wrong, you're screwed. You cannot find anything to resolve. How to resolve? Okay, and this is maybe it's too fast.
Then what do you do to monitor your monitoring solution? Now, how do you make sure that your monitoring solution is not good?
Oh, that's a shiny one. Actually, I'm still learning that. I'm not sure. You use the manager service?
So that's because my company had such a reputation. So the monitoring solution went down, and basically everyone didn't know what happened to production for quite a while until the monitoring solution came back up. My company is like Acronis had a situation where the whole monitoring, like ELK stack, which we did out cluster, the whole thing went down. And it took a while for the whole thing to come up. So like right now, I haven't seen like what exactly they are going to do in terms of to monitor their monitoring solution. So yeah, just a curious question, because I heard from a story from a friend that was talking about AWS's journey about CloudWatch, where they use CloudWatch to monitor their own CloudWatch. So I don't know how true the story is. I haven't, like, until now I couldn't find the article about it. So yeah, just a curious question.
I read an article from the Alibaba. They have a similar solution. So the monitor, not monitor. Yes, it seems to be there's no way to resolve this kind of issue. Yeah. Okay. Yeah. In class is very easy to set up. You just define a YAML file and boom, the class ELK get up. It's very easy to set up use the ELK or return. Yeah. Okay. This is CNCD. Yo. This is okay. So this is lesson 3. When I joined my company, the first one joined my company, I tried to take the initiative to run our system in Kubernetes. There are several choices when I set up the CI/CD. One is using the managed service like the GitHub Action or the GitLab CI/CD pipeline. Yeah, I tried to put our CI/CD pipeline in Kubernetes cluster. So I compare a lot of options. So I think this journey I learned a lot. At first, I compared all these several options in a cloud native way. I mean Kubernetes way. I want to put everything in the Kubernetes. So I compared the Flask, Argo CD, Jenkins X, and Go CD. I compared to the different criteria. Like the community is active and the developers in the repository and the stability. Finally, I choose the Argo CD at last. Argo CD, I very like the Argo CD because the Argo CD, Argo have a ecosystem. They also provide other services like Argo workflow. Argo workflow is used in a Kubeflow. Is quite Argo workflow also can use the CI. I mean, like the CI pipeline. The Argo CD is actually the CD pipeline, and we myself using another one in the action runner. Run the GitHub action in our cluster. The good thing about that is we have the environment in our control, so we can enter the environment to see the step by step, have some log, see something you cannot do in the GitHub pipeline, GitHub action. Yeah, there are a lot of things. During this journey, I learned a lot of things. You see here a lot of ways to speed up the building. I'm not sure maybe you know about it. So at first I use the stable runner. Usually the best recommendation is we're using a stateless runner. So every time you get pull the whole change, if there are commit, you check out all the changes. That way is very slow. If your repository is very big, so the performance is very bad. And so I use a stable runner. The Git have another, Git commander have a very useful command I mean the Git work tree. So each commit, each run, we check out a different work tree. So we build from there. So to avoid conflict, complex. This is a code level and a runner level. I also use the several other Docker hacks. The Docker new technologies, I think the track layer. We also consider use our system is a mono repo. Yeah. So a lot of components put in one repository. So to reduce the building time, I use a lot of context and in the Docker context. So this one can speed up the building. Also using the multi-stage building feature in the Docker in Docker. I also use several mechanisms in the language specific, like Golang. Golang have a cache. Java and .NET all have this kind of cache mechanism. So at first time maybe it's slow. After that, it quite put into perspective. Usually each component will spend about 5 minutes after this feature building feature is off. Three solutions put together, we reduce to less than 10 seconds. Yeah, reduce a lot of time. The building mechanism I'm still learning. This one I tried a bit down. It is very fast. But below the building on based on the dependency, maybe you can read an article from the grab using them. They use these tools can reduce this building time a lot. Another thing is this one is a conflict resolution. In my CSV, we try to after the system compile, we will generate a Docker image. We will put in our what's it? Okay, so this way. I use GitOps principle in our system. If there's as you know, if we have a lot of developers, we will commit a lot of changes. Definitely, there will at the same time there will some changes here occur. So at this time, we will change after the build the image, we will put in the image, I mean the text or the command ID in the YAML file. I use a customization. Maybe you already know about this. Okay. Which one? No? What's my? 我这样可以过来，没关系，这里
先到这里，先把它关了。
OK
再过来4点关。
OK 呀
4点高。
对吧？用这个吗 ？Yeah, it's good. Yeah.
What?
Okay. It's okay.
I think
Maybe the wrong direction. Oh, not the direction.
yeah.
Okay.
That is checking.
Yeah.
Check.
Hi. Oh, it's no.
I think you can do. Yeah.
Hello. Okay. Yeah. I use these tools to customize. I mean, these tools support component based and allows the customization. I mean the same configuration for different environment. And for example, in our system, we're using developer environment and staging environment, and we also have brands. Yeah, this is very useful. Yeah. There's one thing. Sorry. Okay. Okay. This is one thing. After the CI/CD build the image, we try to use the same principle as previously talked about, the immutable infrastructure. So we're using after the image pushed in our Docker image registry, we don't change that again. So we only update our configure file, the customization YAML file in our system. And like this one, I'll show you one. Like this one. We're using a different environment. I like this, that staging. Yeah. And the basic file is the customization file. Okay. Yeah. Like this, we're using a lot of JSON patch. Yeah. The conflict usually happens here in the image. The image part. Everything if we build a new image, we will update this part. Okay. Yeah, good.
5 minutes.
Okay,
8 minutes.
okay. This is a diagram. Yeah. Let's say, okay, yeah. This okay. Okay. This is Argo CD, their diagram. If you would like, you can check their website. They see the CNI selection. There are a lot of factors that affect our CNI selection. You need usually we consider this cost, complexity, or density, performance, and maintenance cost. And initially, our company is cost sensitive. So I try to use a category. Maybe you encountered this kind of issue before. You see your nodes still have a CPU resource, you still have a memory resource. However, you cannot apply new ports to your system. You also have pending, is not enough resource, like this kind of issue. This is usually caused by the port density in the AWS. Is one specific node type you only can support to create maybe several ports, depends on the node type. If you choose the category, you can create a lot of ports in the same machine, more than the AWS native way, the CNI. However, this one they also have a trade-off. I mean, the performance overhead. My preference currently I prefer using the CNI provided by the cloud provider. Yeah, the performance is better. You less complexity. It's very easy to maintenance. If you use a category, you need to teach a lot of configuration, like a Helm chart. Yeah, a lot of things, and like metric server. Metric server also needs some customization to support the category. Yeah. This is INGRESS and the gateway. At first, our system is using INGRESS, and later I found several issues, like either using Hackaway to support several routing mechanisms, like how to based on the method, verb, or the cookie, how to this kind of issue routing the traffic to different service. Yeah. After several research, go to the gateway. I mean the INGRESS gateway. Yeah. In currently we have a standard like the Kubernetes gateway standards. Yeah, that's similar. The concept is similar. Yeah. The gateway also have a lot of give us a lot of flexibility. We can integrate a lot of CI/CD pipeline. You also can use the Flagger. We can canary deployment and progress delivery. Ingress is the current way in Kubernetes. You can expose your service to the internet externally. I mean the HTTP, HTTPS. But gateway is the new standard. Yeah, it's a new standard. It's in like Subsmash. They have a ESTU. Yeah, you can use the ESTU as this kind. I mean, Subsmash also can use a gateway. Yeah, this support is kind of a mechanism. It's very flexible, and also can integration with the CI/CD pipeline. You improve progress delivery and flags, canary deployment. All these kind of things very useful. Okay, this is my lesson for figures. Maybe 5 months ago, I don't know how to learn something, where to learn advanced technology in the Kubernetes ecosystem. And later on find this kind of stories, data story and post models, post-mortems. I copied from the website and put something I found from the internet in the Google Sheet. I learned this one by one. If you're interested, you can copy them. Yeah. So it allows you see the Kubernetes is quite complex. There's a lot of feeder point, maybe single feeder, single point feeder, and learn about there's something wrong, etcd wrong can get wrong, and also API server can go wrong, and even the node the load balancer, the manual is to get wrong. That's why I learned from here and learn about deep knowledge about Kubernetes. That's all.
I hope it is useful to everyone. Please feel free to follow us by any one of the links here. Thanks for watching. Enjoy your day.